Hi gang, I'm going to go over number 8. So for number 8, you first start with the leading coefficient test. For the leading coefficient test, you have to find the degree of the polynomial. So that's the unfactored form, right? So the degree of this polynomial is a 4. If it's an even degree, it means that the end behavior of the polynomial goes in the same direction. So that would be up at the ends or down at the ends. So to decide which one it is, you have to look at the leading coefficient. Since the leading coefficient is negative, it's down at the ends. If it was positive, it would be up at the ends. So you need 2 factors to decide whether it's up or down. This one will be down on the ends of the polynomial. Okay, the next thing you want to do is factor this. So I factored out a negative 2x to the third, and I was left with x minus 4. So that means that my x-intercepts are going to be 0 and 4. I want to then decide if they're even or odd. So for the first one, since the 0 came off of the x cubed, the exponent's a 3. So the exponent is what determines if it's even or odd. So 3 is odd. So therefore I say it's odd. An odd intercept means that it will go through the axis. It will go through the axis. So then for the 4, that came from here, and this binomial has a exponent of 1. Since 1 is odd, that means that 4, it goes through. So remember, an odd exponent means it goes through, an even exponent means it looks parabolic or that it bounces. Okay, so then the next thing I did is I put down the 0 and the 4. I used the leading coefficient to say down on the ends, and then I used the even and odd to do the rest of it. So I knew I was down here, but this was odd, which means I go through, and then this one was odd, which means I go through, and then I was done. So that was letter A, part A for number 8. Okay, then for the next one, this one was already somewhat factored, so I first had to unfactor it to figure out what the degree of the polynomial is. So this is an x squared times an x squared. I have an x squared times an x squared, which is going to be x to the 4th. So if I FOIL all this out, which I'm not going to do, the lead term would be x to the 4th. There would be other terms behind it, but the lead term would be x to the 4th. And since you're multiplying a 1 times a 1 in terms of coefficients, it means that the lead coefficient on that is a positive 1. Okay, so then going back to the leading coefficient, the degree of the polynomial is a 4, which means it's even. Evens mean that the polynomial either goes up or down on the ends. The positive 1 in front determines that it's up. Again, positive coefficient up, negative coefficient down. So ours is the up case. Then I went to figure out what the x-intercepts are. So from this one I got an x, I don't know if I said this, so let me just back up a second. This first one was factored as far as it was going to go. This one here is a difference of perfect squares, so I had to factor this one. So it wasn't completely factored. I had to finish factoring it. All right, so back to the x-intercept. So from this one, I got a negative 1. It has an exponent of 2, so that means that x-intercept is even. Even means that locally around the x-intercept, it's going to bounce or look parabolic. Okay, from here, I got a negative 3. The exponent here is a 1 on this binomial. 1 is odd, so therefore I say that this x-intercept is odd. That means that locally it goes through the x-axis. On the last one, I got it from here. This has an x-intercept, this has a exponent of 1. Since 1 is odd, I say that this x-intercept is odd, which means that locally it goes through the x-axis. Okay, so then I put it all together. So on the ends, it's up. Oh, let me also say, let me back up a minute. So I put up my x-intercepts, so my x-intercepts are negative 3, negative 1, and 3. Those are my x-intercepts. Then on the ends, I say that I'm up, and then at negative 3, I'm odd, which means I go through. At negative 1, I'm even. So notice that this looks parabolic. And then at 3, I'm odd, so I go through. And it should all snap together. So that's part B. Let me just tag on a little something extra here. So when you're doing synthetic division, so let's say I did synthetic division, and whatever happened here, my output ended up being a negative 1, 0, 0, 2 with a remainder of 2. So again, the last one is the remainder. That one goes in the box. And then going from right to left are the coefficients of the particular degrees. So going from right to left, this would be your constant. This would be the coefficient of your linear term. This would be the coefficient of your quadratic term. This would be the coefficient of your cubic term. So I wrote it all out over here. So the -1's on the cube, the 0's on the quad, the 0's on the linear, and then there's your constant. But you know, if you have a 0x squared, that means that goes away. If you have a 0x, that goes away because it means you have none of them. So the only thing that was really left was the -x cubed, which is there, and the 2. And then it also asks you to put the remainder over the divisor, which I did at the end there. Okay, so then that's the final answer. Okay, gang, I'll catch you in the next video. Bye-bye.